Good morning, class. Obviously, I'm not here with you. I'm on my field trip with my daughter today. I don't know who has the better end of the deal because they're predicting it's going to rain. So if you look outside and you see it's raining, just know that I'm outside at the zoo all day. So I'm not sure that I have the better end of the deal, but hey, it's a field trip and we're going to have fun. So today we're going to talk about 6-6, which is geometric sequences. And in your student journal, it starts on page 193. So if you want to go ahead and get that out. Now, before I jump into geometric sequences, and you don't have to write this down, but I just want to go back for a second. And in chapter 4, which was 4-6 to be exact, but not that that makes a huge difference, we talked about arithmetic sequences, okay? And this is good review, even just for the exam, okay? So arithmetic sequences, if I was there with you, I would say to you, what is an arithmetic sequence? So hopefully you're answering that in your head. An arithmetic sequence is when you go up or down by the same amount, okay? And that means addition and subtraction. So we've looked at arithmetic sequences, and then I believe it was in 6-3, might have been 6-4, 6-3, we looked at exponential ones, okay? And then we kind of broke into exponential growth and then exponential decay, all right? So just kind of knowing that we've already done these types. Now, we didn't do a ton of exponential sequences. We did exponential functions, okay? Now, you could take an exponential function and really make it look like a sequence, but they are different, okay? So first, let me just go back to arithmetic. Arithmetic. I'll just make it really easy. How about we go 3, 6, 9, 12. That's pretty easy to see. We're just adding 3 each time, correct? The formula for this, again, if I was there, I would be asking you for the formula was this. Now remember, this is good review for your exam because I can't give you this on your exam, okay? So what we do is we use the first number of the pattern, and then the N stands for what we're trying to predict. Are we trying to predict the 10th spot? What are we trying to predict? And D stands for difference, so it was a difference of 3. So if we work this out, if we distribute, now we talked about this. This is a backwards, like distributive property. So that would be a 3N minus 3. I like to put my variables first, and then if you notice, these two are going to cancel. So this would be my formula for an arithmetic sequence. Okay, so we did this, and then we looked at some that were not arithmetic. So let me give you another one, and we'll just make it easy here because I'm not trying to be real hard or anything. How about 5, 10, 20, 40? Okay, that clearly goes up by 5, goes up by 10, goes up by 20. So that is not arithmetic, but in a way, it's exponential, correct? Because what we're doing is we're multiplying each time by 2. So we looked at doing the first number and then 2 raised to the x, correct? That is exponential. The problem with this, if we grab our graphing calculator and we type this in, oops, I gotta go back to the beginning here. Notice if we go back to the very beginning, the first number in the pattern, can you see? Sorry, there's a little glare in there. If you see, the first number in the pattern is a 5, but the first number in my pattern here is a 10. Now, if I go back to the 0 spot, I find I get the 5. So this is kind of the difference between arithmetic to exponential. So this right here does not work. Because if I put a 1 here, that's 5, 2 to the first power, that gives me the second position. So what I have to do is I have to alter this formula. That is the definition of geometric, okay? So I don't love this first exploration here. We've talked about this before. Not always my favorite things with a student journal. Some of you do this anyways. I mean, if you take this, what you could do is you just take 64. Notice it's wanting you to times by 0.5. and then they just want you to keep timesing by 0.5 and then filling in the chart. Okay, but I don't necessarily think that doing this really helps you understand the lesson. So let's skip page 193. Sorry, my pages somehow got out of order here. And we should be on page 194. Now, we already kind of did this, the paper folding. So if you want to try this again, I don't want to go through folding the paper. Remember, I showed you that little video where they folded that huge sheet of paper, what they get like 11 or more times, I don't remember exactly. But they want you to come up with a sequence here. So we can do it. They're telling us that it's 1 millimeter thick, okay? I'm going to make myself a little chart. So this is the number of folds, and this is thickness. So on one fold, that would make it be 0.2 thick. On 2 folds, it would make it be 0.4. 3 folds would make it 0.8, and then we could keep going, okay? So notice here we have a sequence. Now, geometric sequences are exponential. So that's where the gray area comes in. When somebody says this is a geometric sequence, it is exponential. It's just has a little slight twist to it, okay? So it says, what is the greatest number of times you can fold a piece of paper? When I did it in class with you guys, I think I got 6 times, which if you keep this going out, 6 times would be 6.4. I think some of you tried to get a 7, but I couldn't get a 7, okay? So if I use this pattern right here, if I use this pattern and I try to come up with my formula, notice I would use the first number and then it's doubling to the x, correct? But watch again if I use my calculator. Hopefully you can kind of see it there. So I'm going to type it into the y equals, and then I'm going to go to my table. And if you notice, I'm off 1. Remember, we even saw this with the allowance. Remember on the allowance on day 30, we were off by 1. So see how 0 is 0.2. I actually really want 0 to be 0.1, okay? So you can either adjust this formula, and you could do 0.1 to the 2 to the x, because this is the 0 spot. Now that would work, but what if we don't have the 0 spot and it's difficult to find? We can adjust this formula by just going back 1, correct? So all we have to do is make this a -1. And if you don't have to look right now because I want to answer this other question, but if you look on the bottom of the next page, notice they tell it to you right there. Now, a lot of times I use X, they use N. The letter is kind of irrelevant, but notice in geometric sequences, we're going to be subtracting 1, okay? So just to finish this up, it says, do you agree with the statement below? Explain your reasoning. If it were possible to fold a paper 15 times, it would be taller than you. Now, I know that's a general question because I'm taller than many of you, but let's work that out. Will it matter which one we plug it into here? Not as long as we adjusted that. So let's grab your calculator and let's type it in. So I'm going to use the one on the left here. So that's 2 raised to the, now it says 15 times. So that would be 15 minus 1, which is technically 14, okay? So that comes out to be, at 15 folds, I would get 3,276.6 millimeters. Now, I don't know my height in millimeters, but I do know in 1 foot, there's 304.8 millimeters. So why don't you quick do that conversion for me and tell me what this is in feet, okay? So if you need to, you can pause the video here. Go ahead and convert that to feet. All right, hopefully you converted. If you don't remember how to convert, just really quick here. You take the number that you were given. You do what's called an action line. You put the same unit on the diagonal. So there's 304.8 millimeters in 1 foot. You always put the units on the diagonal. That way the units will cancel. So all we have to do is take that number divided by 304.8, and it tells us it's about 10.75 feet. So 10.75 feet. So if you could fold a paper 15 times, would it be taller than, or would the thickness be taller than you? And the answer is yes. Okay. So they're just trying to kind of give you a comparison, you know, if you have a large number, plugging it in and comparing it to something that you know, like your height. Okay. So essentially that's geometric sequences. So if we turn to page 195, geometric sequences, kind of like exponential, is when you have like a common, well, it's right there, common ratio. Okay, and then the common ratio is kind of like, what are you multiplying by? Now remember, again, the only difference is that you have to watch because you don't have the zero pattern. So right here, if we look at this, if we were to do this exponentially, what we did, again, it was either in 6.3 or 6.4, I think it was 6.3, you would have done 1, because it's the first one, then you would have done the multiplier to the x. But again, if you plug in position 1, so this is position 1, position 2, 3, 4, if you plug this in, you're going to be off by 1. So all we have to do to correct this is subtract 1. That makes it geometric. Okay? So that's what you basically have to do today. So it's not too bad. Again, when I knew I was going to be gone, I kind of picked today because I didn't think today was all that difficult of a day. So just remember, a sub 1 is the first number in the pattern, r is your ratio or the multiplier, and then n is what you're trying to predict. Or sometimes I use x. You can use whatever letter you want. Okay? All right, so let's go to some examples here. Again, sorry, my page just got a little bit out of order. All right, page 196. We first just have to tell if it is arithmetic, geometric, or neither. So again, I wish I was here with you because then I could ask you guys. So when I look at this first one, I'm noticing that I'm timesing each one by -4. That is geometric. Remember, we technically don't have exponential sequences. We have exponential functions. This is an exponential function, but it's also a geometric sequence. So you have to really watch the words here, okay? I'll do one more with you. So when I look at this one, I'm noticing I cannot multiply on that. There's nothing that's going to multiply 3 to get to 7. So on this one, I'm going up by 4. So +4, yep, that works, which means it's arithmetic. Now, if you wanted, I could write you a formula for arithmetic. It doesn't ask me to, but I could write you a formula. It's the first one plus n minus 1 times what I go up by. And then, yeah, I probably should clean that up. I should distribute and so on. But they're just asking me to give it, okay? So why don't you pause it here and go ahead and try 3, 4, 5, and 6 and just tell me which ones they are. Okay, hopefully you paused it. Number 3 was neither, because if you notice, it's timesing by 2, but then right here, that should be a 16. So this part right there breaks your pattern, so that's why it's neither. This one is also a neither, because if you notice, it's going down by 3, and then it goes down by 2, 2. So this part right here is not the same. This one is geometric because we are going up by, or to multiplying by 3 each time. Now again, I can write you the formula. That would be 6 times 3, and then if you want, n minus 1. Again, the only difference is that because this is the first number in the pattern and not the 0. Now, if you want to find the 0, so notice since it's going up by 3, we could divide by 3. So the 0 would be at a 2. We could then write our formula from there too. So there's lots of different ways you can actually do these, okay? But they want you to get focused on geometric. All right, number 6, this would be arithmetic again because you're adding 8. So this is arithmetic. But again, it's good for you to practice the arithmetic formula because it's on the exam, and your exam is coming up in about a week and a half, okay? All right, number 7 through 9, they're just telling you these are geometric sequences. So once again, the nice thing is they're telling you it's geometric. So you just have to figure out what they're being multiplied by. Notice, even if it's going down, you might think in your head that you're dividing, but we can also multiply by the fraction, okay? So this one, we're multiplying by 3. So it might be just faster to type in 189 times 3 in your calculator, okay? If you want to write out the formula, you can, but it might just be easier to go times 3, and so you get your first number, and then just go times 3 again, and then times 3 again. The reason why the formula is nice is what if they ask you to predict the 100th term? You're not going to want to sit there and go times 3 times 3 times 3 times 3 all the way out to 100. But if they're only asking you for the next couple terms, then using your calculator is really not all that bad, okay? So the next one, like we said, this is going down. So you might think that you're dividing by 2, but when you do the formula, you're going to have to say multiplying by 1/2. So if we take 72 and divide by 2 or multiply by 1/2, we would get 36, then 18, then 9, okay? Same thing over here. Notice we're multiplying this time by a -2. So that would be 80, 160, and then positive 320, okay? The next part, you guys don't have to worry about graphing these things because they don't really ever worry about graphing the sequences, so we can skip this section. If you want to try to graph these things in your graphing calculator, I mean, really what they want you to do is like, okay, the first spot, you go all the way up to 12. The second spot, you go to 6, and then you just graph them. You can do these under the stat key of your graphing calculator. So we just have positions 1, 2, 3, and 4. So I don't have these other positions. So I'm just deleting them real quick here. And then up here would be 12, 6, 3, and 3 divided by 2, okay? And then the only problem you have to do is you have to turn on your stat plot. So you go to stat plot, and then you have to turn this on. So see, I have to highlight the on position. Now just be careful, if you have anything under your y equals like I do, you got to clear that out too. So I've got my stat plot on, I've got my data typed in, and now I can hit graph. So they just want you to notice that this is the same shape as exponential growth and decay. That's all they want you guys to notice. So I don't really think graphing these is really worth your time. I did not have you do any of those in the homework, okay? Okay, then the last part is writing. Notice they give you 3 different types. They give you the sequence, they give it to you in a chart, and they give it to you on a graph. So these are all the same type of questions, it's just how they present it to you is different, okay? If you don't remember the formula, if you want to write it up here at top, it's a sub 1 r and then n minus 1, which again, the only change is the minus 1. So right here, we have got the first term times, we need the multiplier. So notice this is going down, but if you don't recognize the number, then grab your calculator and just go ahead and divide it. And it is going to be consistent. But if you want to give it a try just to make sure, try a couple of them. Make sure that they're all going down by the same amount. And if you notice, they're all going down by 3. So that means we're multiplying by a third. And then we do n minus 1, or you can do x. Sometimes I do x by just habit. And now they want me to find the 6th term. 6th term wouldn't be too bad because notice this is 1, 2, 3, 4. So it would not be that hard just to go 243. This would be the 5th term. That would be the 6th term. That wouldn't be too difficult. But what if this wasn't 6? What if it was something huge? So let's just plug this into the formula. So I'm going to got the 1/3. Now, if you've got the 83 and you're actually going to type in 6 minus 1, you might want to put it in parentheses. I suggest just doing that in your head because it's easy. 6 minus 1 is 5, okay? But you just have to watch if you have the 83 calculator versus the 84. Notice I got the same number, which is 27. So I don't think predicting the sixth one is all that bad. Maybe on this next one, we should predict something larger, okay? So let's write this one. We've got the first number in the pattern. Notice you're multiplying by a -3. See how it's going up by -3? So that's -3 n minus 1. So let's pick something bigger. And if I was there, I would ask you guys. I'm sure you're probably thinking random numbers. How about 50? Let's just do a 50. There's no way I want to sit there and keep going times 3, -3, 50 times. Okay? So I'm going to type it in my calculator. Again, 50 minus 1 technically is 49. Notice that's a huge number, isn't it? So it's -1.9 times 10 to the 24. That means the decimal point is 24 places over. So it's going to be huge. But that's okay. It doesn't matter what it is. We can still write it down. Okay? All right, why don't you go ahead and pause it here and quick do 15, 16, and 17, and go ahead and just, how about do a to the 6, just because that's what the paper says. So go ahead and do these 3, and then we'll talk about the graph. All right, hopefully you paused it. The formula should be 3 times 5 to the n minus 1, and then if you do the sixth one, if you plug the 6 in there, you'll get 9,375. Down here, the first number in the pattern, and then notice it is going, what, down by a third, correct? Dividing by 3. Sorry, I just didn't write that one down. Yep, so it's going down by a third, so I've got to do 1/3 and then n minus 1. Sorry, I thought I had these written down. So I'm doing it to the 6th, so that means a sub 6 would be 12. All right, the next one is an 11, and then notice I'm going up, timesing by 4 each time. And then if I do a sub 6, I believe it's 11,264. Okay? All right, graphs, real quick. The graphs are no different. The nice thing is you have the you have the first term right there, wherever it says 1 comma. So you've got the first term, so you just write that down. Now just look at your y values. From 2 to 6, notice is timesing 3. 3 times 6 is 18. You might not know 18 times 3, but you can quick check it. Notice it is 54. So we're still timesing it by 3, and then this would be our n minus 1. And then if we plug the 6 in there, so technically that's to the 5th power, we get 486. Okay? So please do not let the graphs be that difficult for you. They really aren't any more difficult than the charts. You just have to kind of look at the y values. Don't let your eyes focus on the x's, okay? So I'll quick jot down the answers to these last ones, just in case if you want to try to practice them. So then this would be 8, and notice it's going down by a 4th. And then a sub 6. This one comes out to be a fraction. It's 1/128, which is 0.0078. If you do get a decimal, just jot it down. It's no big deal, okay? So hopefully geometric sequences were not too difficult. Just remember this is your formula. The page that we had been working on, this page here that we had been working on with your properties, that's not the right one, sorry. Too many papers here. Your geometric sequence properties here, we had been working on this. If you want to go ahead and fill that in, you can fill your formula in. You just want to fill that formula right there into your box. That way, if you're using this to study, you're kind of keeping it up to date. Okay? All right, work hard on your homework, and I will see you guys back on Thursday. Have a great day.